Good afternoon, everybody. Welcome to this webinar on baseline approach, baseline generation and comparisons. This is the second webinar that we have for the V4SAFETY project. My name is Sietse Kalesvaart. I'm from TNO. I'm the coordinator of the V4SAFETY project. And today we have a very interesting and also technical webinar on baseline in a wider sense. So we have three speakers today, and let me introduce them to you. So first of all is Felix Varenkroch. He at BMW. He is an expert in virtualization of integrated safety and work package lead for the safety assessment framework of V4SAFETY. The second speaker is Christoph Glasmacher. He is a specialist in scenario-based assessment at IKA in Aachen, and he's work package 4 lead for the baseline approaches. Henry Chaimowitz is from Lab France and Renault, and he is work package leader for the use cases in V4SAFETY, but also very much involved in comparisons, tool comparison, baseline comparison, etc. So he is our third speaker. Let me tell you a little bit about the project. So this is a Horizon Europe project that is ending this September, 3 years long. It's on virtual evaluation of safety. This is very much on prospective safety assessment. So we're talking about looking ahead, what safety measures might improve the safety, the traffic safety, and how can we simulate them and get more certainty what options are best. There is a big emphasis on transparency of this simulation-based framework. So all of the decisions made in selecting models, selecting baselines, configuring the simulation environment, etc., are transparent based on the V4SAFETY framework, which helps to really make studies, simulation studies, more comparable. We're looking at vehicle technology, but also at safety measures in infrastructure or behavior. Behavior could be either change traffic rules, but it can also be the training or changes in the driving license, or it can be other regulatory measures. So in the end, we want to increase reliability and acceptance of simulation. We know simulation is a given in automated driving and in safety assessment of modern vehicles as well. So let's do it in a proper way, and V4SAFETY focuses on that. No. Okay. If we look at the objectives, that sort of summarizes this. So a predictive assessment framework for road safety. Then we also need behavior models. So models about human behavior or driver models for automated driving functions. So that's an important topic. Then baseline generation, that's our topic for today. Then the use of models for safety measures. So the technology that is modeled to assess their contribution to safety. And we demonstrated all this with use cases. And we also created a methodology for projection over time and extrapolation across regions. So say you have an analysis in Germany. What does it mean for France? What does it mean for Hungary? We are connected to 2 harmonization and standardization bodies. So one is PIRS, and the second one is an ISO working group. If we look at the projects, there is, you see the partners at the right, and at the left you see the work packages. The gray circle here is work package 2 on the prospective safety assessment framework. That's sort of the central work package for the whole project, defining the workflow, the methodology, etc. And then there are more specialized technical work packages in the middle, 3, 4, 5, on human in simulation, modeling the baseline, and modeling safety measures. And then there is supporting work packages around it. So if we look at this webinar, it's the second in a series of 5. The previous one was on the full framework. If you missed that one, Felix will still do an ultra short introduction on the framework. The next ones are on simulation structure and the processor, the V4SAFETY processor that helps you to build up your simulation structure. The fourth one is on projection and extrapolation. This is where you will see Henri back as a speaker. And the fifth one is on human models by Jonas Bergman and others. So those are the webinars that we will have, and you're much invited to join, of course. Then this is the end of my introduction, and I hand over to Felix Varenkroch now, who will give you the first introduction on the baseline approaches.
Yeah, hello also from my side. Happy that you joined today this webinar. As said, we're talking today about baseline approaches. However, before we go into that, I think it's good to have a look again on the V4SAFETY framework. We have split it basically in 5, we call it themes. So these are the overarching topics and then the different topics below that. Today, we will focus mainly on the preparation of the simulation. So you will see later in Henri's part also simulation results and some simulations, but I think in particular Christoph and my part are more on the preparation of the simulation. And obviously we have one topic dedicated to select the baseline approaches. However, it is closely linked, as you will see later, to prepare data and select models. The first part, and I think you all are more or less familiar with different kinds of study, but we always think it's a good reminder to tell you why the baseline is so crucial. In these prospective safety assessment, safety performance assessment by simulation, we typically talk about a comparison between baseline and treatment, and baseline is the condition without the safety measure present, which should be assessed, and treatment is the condition with the safety measure present. And basically you want to compare that. And I think it's obvious if you implement the safety measure right and not right, then you will get the wrong result for the treatment. This is pretty obvious. However, the modeling of the baseline is equally important, since we talk about this relative delta or the current delta between baseline and treatment. If your baseline is at the wrong position, then you will get also wrong results. So this is a very essential part, and this is the reason why we put also a lot of emphasis in our simulation framework on that topic, and we'll explain it also here in the webinar. One point, of course, I mean, always have, I will present you on the next slide different approaches. You can have the best approach. If your data and your models don't fit that approach for the baseline, you will also cannot proceed with this simulation. I will go into that on one of the following slides. And what was good for us is we had basically a bit of previous knowledge which we could use, and this was basically the work from PERS and the ISO technical specification, which you see on the slides, the 21934-2. And we continued the work which was started there. And in that perspective, it's maybe also important to underline once more why we think, why we took an effort to classify different baseline approaches. We know from the past there were many different approaches, and if you want to talk about or compare results, then you have first to check, is this really the same baseline approach? Have different approaches be selected? And instead of explaining all the stuff which you have done, we thought it's better you have a kind of classification. And in V4SAFETY, we started, as said, from the ISO technical specification. And this is basically also the first layer which we have here, where you decide on the main baseline approaches. And we distinguish here between approach A, B, and C. A means you have one original case. And this could be recorded data from a naturalistic driving study or an FOT, but it can be also reconstructed accident data. So GIDAS PCM would be, for instance, one example. And you aim then really to simulate this scenario without any major modification. Then there is one approach, which we call B, simulation of original cases with modification. So it's quite similar. Again, you start from a concrete, original, recorded, or recalculated situation, but you think these times I would like to add some modification. This could be changing some parameters to account for uncertainties. It could be also to add a certain system. So if you have very old data and you want now to consider an ABS system, then this could be also an approach. And then we have the approach C, which we call syntactic generated cases. And syntactic might imply a bit, we come up here with artificial scenarios. This is explicitly not meant. However, the C approach does not have a link to a certain real-world situation. However, it's important to bring in the mechanisms which link these generated cases to original cases. So it could be distributions, it could be models which are generated based on original cases. So for sure, it's not enough to have only one case. You will always need more cases, and use these mechanisms to generate then or to sample new cases. So this is the first layer. And then on the second layer, we go a bit more into details how you handle now the, or how you treat the cases, whether you increase or you decrease the number, basically. And if we stay with the A approach, then it's pretty obvious. Since you don't add any modification, you will have the same cases as in the database which you used. You will use also for the assessment. And this A0 is already one of the additions which we added to this, or where we extended what has been described in the ISO specification. When we talk about approach B, of course, you can stay also with the number of cases which you have. But in contrast now to the A0, you probably add a certain system. Therefore, you have a modification in, but you don't change the number of cases. With B, you can also come to the point where you increase the number of cases which you're simulating or put into your assessment. Because, for instance, you consider some variation of the starting conditions to account for uncertainty. The approach C, we see two combinations. One would be, of course, also case generation. This is basically when you go into hundreds or thousands of simulations to cover a certain scenario space quite well. So this would be C2. But we think also a C1 approach is possible. So where you get maybe have multiple cases, but you select basically out of these cases some representative one. This is, for instance, technically a bit going into the direction like in your NCAP test scenarios are selected. And now the question might be, why should I reduce the number of cases when I'm doing simulations? Because typically they can be run fast. Yeah, typically, but there might be simulations which are quite resource consuming. For instance, if you combine or if you look into passive safety measures, then the simulation can be require quite an effort, and in that case, it might make sense to reduce the number of cases which is analyzed. And then we have added also a third layer, and this is basically where we differentiate between P and I. And P stands for pre-simulation, and I stands for in simulation. And this describes how you get to your trajectory, or basically the movement of the relevant traffic participants. If this is calculated prior to the simulation, then it's a P approach. If you use any kind of in-simulation model, for instance, a driver behavior model, then it would be an I. However, it does not necessarily need to be a human driver model. It can be also technology. If you think there is some automated vehicle, for instance, involved in the baseline, then this would be something different. So there is also a subclassification to the I, which is not shown on that slide. But basically, what we aim here is really to describe in a very short form how you got to the baseline. And when we talk about the baseline, maybe one or two comments also with respect to the interdependencies, and this is particularly with prepared data. Christopher will go into that in a minute, and select models. Basically, if you don't have the right data to make or not enough cases to do, for instance, baseline approach A, then this will be not feasible. So if you have only one or two cases, well, probably the other approaches might also be hardly possible. But this might be a limiting factor, or if you miss the right data for your approach. And the same applies for the models. If you want to go for a C approach with an in-simulation model, but you don't have the quality in your driver behavior model to do that in that scenario, well, then you can't do that approach, and you might need to go to another approach or revise the evaluation scope a bit with your stakeholders. This might be then points which need to be discussed, but it's very important, and this is why we included that slide, to be aware. I cannot only decide on an approach if I haven't considered what kind of models and data are available, and also the other way around. If I have an approach, I need to check with the data on models which are available. To make your life a bit easier, we have produced in V4SAFETY one template to select a baseline approach. It might lead, so you fill in some questions with yes and no, and then you have to select or get a suggestion about the baseline approach, which might be most suitable. However, there might be, of course, internal reasons to switch to another one if, for instance, two results are close. See it as a suggestion to help you to pick the right baseline approach. And with that, I will leave it with the introduction, and I would now hand over to Christoph. However, I don't know whether there is already some questions which you can ask in the button Q&A next to the chat. If there is no immediate question, I will stay on the call. However, Christoph, then you can continue and take over, and then probably we handle the questions at the end.
Yep.
Just one comment on the Q&A. If you can't find the button, it's also in Teams under the More menu, so the three dots. You can find it there.
Okay, with that, then I would take over. Thanks, Felix, for that introduction. And let's now assume that we have selected the baseline approach, for example, from the template Felix just introduced. Then still the question is how to actually come to that baseline. So how to really realize that baseline approach. And that was basically a whole work package which we had in V4SAFETY. And basically thought how to do that. And that caused a bit a challenge, I would say, because what you've seen is that we have defined not one baseline approach. So one way to create a baseline. No, we have created 9 different ones. Not all of these approaches are always suitable, but still they exist. So what we had a look at how to actually represent or create a representative baseline for a certain evaluation scope. And to do that, we have created different workflows for that baseline approaches, because all of these baseline approaches do need a slightly different approach, though also some parts are of course similar. So since we want to create a representative baseline, we always, or our first step is always relying on data or assessing which kind of data do you have available to really know, for example, what kind of accidents are there, what's the severity, what's the frequency. So we always start with that kind of data, maybe different data depending on the evaluation scope, may depend on the baseline approach. Basically, we normally have to handle that data or work with that data we have available. And then we do process that data and extract scenarios, test scenarios with certain steps in between depending on the baseline approach. So for instance, if we use a so-called A0P approach, which was that one where we just take the cases from our data sources more or less as is without any major modifications and simulate them, well, then the processing steps in between are normally not too big compared to C approach, for example, where we do have to build distributions and sample out of that, for example, for the C2 approach. Therefore, we do have created 9 of that flowcharts, which you can see here on the right. Don't worry, I don't want to go through all of these, but we basically have developed them for all, so that there is a loadable just to look it up once you have decided which one you want to choose, and then you can go exactly in that specific part, more or less as in a wiki. Here then maybe also just be a short reminder, since that is quite a broad topic. We actually have generated 2 deliverables. One really just about the data sources, since that is really the core to build a baseline. And then the second one about the actual process, how to come from that specific data then to scenarios which can then be used for simulation. So yeah, so I would quickly go through these, and as said, data sources are the most essential one, or one of the most essential ones, since that's really our input, which we then use. And therefore, basically what's important, that data always have certain limitations. They normally always have certain bias, maybe bigger, maybe smaller, though that has to be accounted for, as well as the amount and general quality of data we do have. So therefore, we have categorized 23 different data sources, or data source categories, sorry. And that we basically can use for assessment, and basically have to evaluate which ones make sense for a certain part of the frameworks. Therefore, we have developed certain requirements in the framework itself, and then have applied them in terms of data, what's actually important for certain data sources for certain steps in the framework. So what you can see here is basically the colors you've also seen for the framework itself, and then where a certain requirement applies. So naturally, for example, for prepared data, it's quite a lot of them, whereas for the actual simulation, where it's more about the execution, there are not too many requirements on the data itself, but more in the beginning and the end. But yeah, those requirements we have then set up, and last but not least, we have to ensure that we do have a certain data quality. So already said that we do have certain limitations, but so it's important that we are able to grade our data in terms of completeness, in terms of the bias we do have in the data. So therefore, we do have we've set up certain grading categories to really assure that we do have a good basis for our baseline generation afterwards. And within that baseline generation, we do have basically defined 5 different steps. First one is really selecting the data, doing initial processing, and maybe also doing some merging. So for example, what you can see here on the right side, it may be sufficient if you have your perfect one data source, which you can just use. You can process the data and that's it. In reality, you may have different data sources which you may want to use. So therefore, you want to be able to merge them, have to align references, have to align biases, and maybe even rating those data sources so that you can afterwards then use that to, for example, creating scenarios, which then is actually the second step. So once you have the data, you want to make sure that you categorize that data and create test scenarios out of that so that you can really use them in the simulation. And well, then we do have certain steps which are rather optional depending on which baseline approach you're choosing. If you're just having an A0P approach, so basically taking our cases as is, then we do step 1 and 2, that's fine. If we do a generation for our C approach, so that syntactic cases, we don't take the cases as is, but we're building distributions out of that, and then sampling again out of that distributions. That's basically then that step, which is basically important for that C2 approach. And Felix also introduced that we do have P and I approaches, where P means that we do have a predefined trajectory, but we can also have I, meaning in simulation models, meaning that we do have simulation models, which could, for example, be driving behavior models, which could be technology models or sophisticated models. And once we use one of these in our simulation, we of course also have to incorporate that in, or we have to account for that in our scenarios. And that's basically then that utilization of that in simulation models. We have to make sure that that fits to how we created our scenarios and how we categorized our scenarios. And the last one is then more for the evaluation. So sometimes it's sufficient just having a look at collisions. Sometimes you really want to have a look at injury risk. And that was basically the last step where we thought, okay, how can we actually utilize the data we do have to create injury risk functions? Since that's quite a lot, we basically said, well, we show the opportunities. We tell how to come to decisions and which kind of assumptions to make. And basically, we focused a lot on recommendations to give how to then really process the baseline generation for a certain evaluation scope, because depending on that constraints you may have to generate a baseline that can be rather different. Yeah, maybe then just really short example on our second step. So therefore we said we want to create scenarios from the data. So we have to categorize, to group them, which is particularly important for generating distributions to account for specific model requirements for model ODDs, which we may have, and then deriving test scenarios out of that, which then really suits the evaluation scope and also the other constraints we do have. So the example you can see here on the right is basically one from our use cases actually, where we parameterized a trajectory for a P approach and then used that in one of our assessments. Now, one last slide I do have, and that's a bit broadening the scope, is that mainly in V4SAFETY, we talk how to come from assess with data quantitatively, yeah, and get a certain result. Though that's not always possible. So, and yeah, one placative example for that is what actually what's if another pandemic would break out? What is if something happens where we don't really have data or not sufficient data? And that's also what we had a look at, and we called that future traffic scenarios. I said especially those where we don't have data for, and therefore we added our quantitative methods with so-called qualitative methods, which may be Delphi studies, expert panels. And for that, we of course also start with an evaluation question and then evaluate on which parameters or which parameters may be affected, and then see whether we can approach them qualitatively or quantitatively, and then either use that as an input for our quantitative assessment, or, and that's also can also be a valid option if the assumptions are quite essential, for example, stick with a qualitative assessment and then deriving conclusions from that on. Said, so both are relevant. Normally, we always want to be here in the blue path, so doing it quantitatively, though if that's not possible, we also added that second option, that qualitative method. Okay, that would also, or that would be for the short overview of the baseline generation. Thanks. Of the baseline generation. So as said, quite a lot of different approaches to take, a lot of examples and choice to make. But to there go really to the specifics. I think there's best really having then a look at the deliverable or at certain questions. I'm not sure, are there any questions right now for the baseline generation part?
And you can raise questions in the Q&A, which is under the More menu, or raise your hands and then we'll open your microphone. Okay, in the meantime, Christoph, I have a question to you. So you talked about baseline data and data grading, etc. But are we always talking about accident data? Is that what we need, or is there other sources?
Well, that actually highly depends on our evaluation scope. So, for example, let's assume that evaluation scope asks to reduce a certain crash rate. Well, yeah, then we should really have crash data, because if we then just have naturalistic driving data and without any crashes, it's rather hard to transfer that, or basically to use that with a completely different severity to draw any conclusions about crashes. Though the other way around, if we say we are not interested in crashes itself, but we are interested, for example, in near misses, that we want to prevent these, it becomes, I think, a bit more tricky, because then, of course, we do need other evaluation criteria. So we have to think of which would be our evaluation criteria, maybe as a TTC or whatever. So, well, yes, that we can do. Then we also have to have the data for that. And that's, of course, can be completely different data. So no, we don't always talk about crash data, but typically a lot of these assessments are about evaluating whether we can reduce crash rates or whether we can decrease the risk in terms of collision or accidents in general.
Clear, thank you. So if we want to know about crash rates, we need the crash data. And if we want to know about more regular driving and less critical driving, then you might set up a study that is based on naturalistic data, if I summarize correctly. Yeah. Good. I also have a question to the audience. I'm curious how you will use such approaches and how do you do that in daily practice. So if you're willing to share something with that, you can also tell in the Q&A what is your application for such baseline approach and data approaches. In the meantime, so Christoph, another question. Data availability is always an issue, it seems. So it's very often a bottleneck in making a study. So V4Safety did a lot of work on baselines and also on analysis of data sources. But in what way did V4Safety help to get through these data gaps?
Really nice question, I think. I think V4Safety really helps to show on the one side the limitation, so to really show where's the gap, what actually should be considered in terms of, for example, what are influencing factors which are relevant, which has to be considered also as gaps and limitations. So showing that gap on the one side, but also we have that different baseline approaches, and for the different baseline, or depending on the data you do have, you may use different baseline approaches, and we offer quite a list of tools how to then make certain assumptions about the data, bridging that. Of course, would have to be stated that as limitation and assumptions, though also if you don't have a lot of data, it may still be possible to create a baseline, then depending on the approach, and then having a look at certain tools. In the end, still, so we address that, though it has to be quite clear that if you don't have enough, or the assessment itself can only be as good as the data is.
Mm-hmm. Okay. And if I have very little data, can I say then that by definition approach A and B are most likely, baseline approach A and B, or is it not that simple?
I wouldn't say it that simple, to be honest, because it highly depends on the data you do have. So for example, let's say that you do have just a handful or a couple of cases, but you do know them pretty well. Then, of course, an A approach may be a good one if you know your cases really well, and you can also say, yes, they are representative for something. Then I think for sure that's a good one. But yeah, that highly depends on the data you do have.
Yeah. Okay, thanks. We'll have another questions and answers time slot after the next speaker. In the meantime, I paste in the Q&A a link to the outputs page of V4Safety, where you can find corresponding deliverables. So there's one on data sources, there's one on the framework instruction, and soon there will be also another one on the full framework methodology. So please follow that site. There will be a lot more in the coming month or two. So then let's move on to our next speaker, which is Henry Chaimowitz. No, which is Christoph Glasmacher, and because he has more to tell. Christoph, go ahead.
Yeah, then I'll just go ahead. Henri, I think you'll be the next one in a couple of minutes, but let me just go about that baseline comparison first. So now we have generated a baseline, though a big focus is also whether it's really then comparable. So let's assume that two different entities have performed a study, and we now want to know, well, can we compare them? They have different results. Why do they have different results? Because the treatments are different, or what's actually the case, or where's the difference? And since we do have to make a lot of assumptions when generating a baseline, we have also seen that we do have different baseline approaches. What we did here then in V4Safety, we had a look what's actually the influence of that. And for that, we basically took one use case with one evaluation scope, basically having that example here. So what's the percentage of avoided and mitigated crashes in a car turning right, cycle straight in the same direction scenario, if an A/B is implemented to all cars in Germany. So one question, And we basically had 3 partners doing 4 assessments. So one partner did actually 2 assessments, approaching that issue. And before I go in the results, I just want to highlight shortly what have they done. So we do have 2 B0P approaches. Just to recall quickly, B0P means that there are slight modifications to the existing cases with a predefined trajectory. We do have one B2P, which is slight modifications, but then generating new cases out of that with a predefined trajectory. And we do have a C2P, which is basically then that syntactic case generation with pre-simulated or with predefined trajectories. All partners in that case worked either with PCM data or with GIDAS data. So actually, yeah, quite close, but with different years they had available. So basically all in the range between 2000 and 2023, but depending a bit from time to time, data location and also the timing they had available, which made it, which actually makes it also more realistic. And depending on the data they had, of course, they also had a certain number of available cases fitting to that specific example or evaluation scope. For that evaluation, we don't only have a look in the end at one number, because yes, we could just have a look at one number, and I'll show you that one number in the end. Though it's also interesting where deviations come from, because the baseline generation I've showed is not just one step, but it includes multiple steps, which we then also investigated. So first of all, having a look there at the original data. So I've shown that they had different data available. So we compared that one. Then we compared the process data before a simulation. So basically account or weighting data and basically accounting for certain data bias, which may be in the initial data or which may be in the original data source. Then we have made a simulation, or then the simulation was made. So that's basically then a third step. And in the end, I'll show the example compared to the or the result compared to the treatment. And yeah, just would go through all of these steps one after each other. And maybe let me explain first of all here the picture, what you can see. You of course have different parameters which you use to generate your scenarios, and in the end, of course, to get a result. And what you can see here is always just for one parameter, the cumulative density function. Meaning that here, for example, we do have the initial speed of our vehicle. And then we, for example, know that at 20 km/h, we do have approximately half, or basically all occurrences are from 0 to 20 km/h. For a certain assessment. We of course always have here 4 lines because we do have 4 different assessments. If we now have a look at that and just recalling, we do have GIDAS and PCM data, which is actually quite similar, but still, of course, different granularity to some extent. Also, not 100% the same data. So what we do know, what we can see, is that we do have differences in that data. And that you can see, especially here on the right side, and I just marked it here in red, that if we just have a look at the collision speed of the bicyclist, then we have a jump at 10, 15, 20, 25 km/h collision speed bicyclist. Whereas naturally you would think, well, it should be more or less a continuous curve. Though we do have that jumps, I think especially in the PCM data, if I'm not mistaken. Why do we have that? Because when data is collected, it seems to be more natural that those collecting the data say, typing in 10, 15, 20 instead of 12, 13, 14 KMH. So there we can naturally see that we already have a data bias, which is actually not the same for GIDAS and PCM, but it's also not the same for example, Dresden and Hanover. So there we do see that those peaks, are not the same, but look a bit different. So already in our first step, we do have a certain data bias which we have to account for. Therefore, we do have our second step, and in our second step, just to recall, that's our processing. And in our processing, we account exactly for that kind of data bias depending on our baseline approach. So for our B0 approaches, we can weight individual cases, that for sure. But what we can do, what we do for our C approach, and that's what you can see here on the green line, is that we can now use for the C approach a distribution modeling function. In that case, I think just a regular PDF function. And then we do see that we get some deviations due to assumptions which are made for that C approach, that we may have more, or we do have a longer tail for that, and therefore do have here, not so many initial speeds, or the distribution of net initial speed is not too high then in the mid-range, but we increase that a bit to the longer range, which was basically the assumption a partner made. Though we do, of course, get uncertainties for that. And what you can see here as well, just to go quickly over that, we made their pairwise comparisons between the different assessments, so between 1 and 2, 1 and 3, and so on. And they had a look at the maximum deviation, which can, of course, to some extent be lower or decrease or increase from step to step. So we've seen that we now also get certain deviations from our step 2, but other deviations, we can actually reduce due to that weighting. Afterwards, we do have then our simulation, and there is basically just the difference between how the scenario is actually interpreted, how the different models behave. All of the A/B model used was aligned before, so there shouldn't be a big difference. But actually, I don't want to go too much into that simulation comparison, because Henri will talk about a simulation or tool comparison afterwards. We are way more detailed, but just so much right now to show that, well, we are in the end pretty close for the collision speed between these assessments, though we do see that we do have quite a big deviation than for the more geometric values, which you can basically see here on the right side, especially between assessment 3 and the assessments 1 and 2. So between, and 1 and 2 was more or less PCM, and 3 and 4 was more or less the GIDAS data used. So I said, not going too much into the simulation itself, but having then a look at the results, and that's what I promised in the beginning. We do have 4 different assessments. We do have one question which had to be asked. And now, ideally, so all followed the V4SAFETY framework, we should have one avoidance rate, which should be ideally the same for all. Though we have seen that we, of course, do have certain deviations because some assumptions have to be made. We do have certain data limitations. We do have different simulation tools. So what we can see is that we do get avoidance rates between 4.9% and 14.2%. So they're all, and I think that's quite important, are all in the same range. And also having a look at the confidence intervals, most of them are overlapping, though it's important to mention here that the confidence intervals are only based on the mathematical or statistical calculation and do not include biases or assumptions made within the assessment. Though I think here we are really rather close, but it's important to mention that we do have that deviations due to data bias, due to the assumptions, which can be different between the different assessments, and then of course also to the tooling. So therefore, that to conclude, for comparison, yes, we can see that we do have deviations. That when comparing two assessments, we do have small deviations. It's rather hard to say whether one is really better than the other one without really having a look in the data and having a look at the assessment and documentation. Though, if that's done properly, they can be compared, and I think that's quite a nice result. And with that, I would first take your questions and then would leave it then for the deep dive to Henri to go a bit more, especially in that tool and simulation comparison. Are there any questions for that comparison?
Yeah, question from my side, Christoph. There was an effort to harmonize models, though we didn't insist on that, just to reduce the parts of the variation that would be coming from the models themselves. So some models have been commonalized, right?
Yeah, that's correct.
Yeah.
So that was it was really the purpose more to have a look at the baseline generation and not too much on the models itself. Yeah.
Yeah.
So in the, as you explained, the data sources were very much PCM and GIDAS, so very comparable. And there were some differences also in the years of the data. So the age of the data in a way. Did you look into any consequences of that?
You mean the consequences of ages in terms of that we would have done two different assessments with two different years or time spans?
Yeah, so some of the analysis were implicitly using different years of data than others.
Yeah, so that was basically due to that fact that basically that data was available for then a certain partner. So it was always the case that they used the reasonable data for that. The year, basically that was also accounted for in the rating. So depending on the years they used, they of course had different rating factors for that to account for, because in the end everything was, I think, rated to 2023. Though what we haven't done is we haven't done the two exact assessments, but just taking two different years. No, that we haven't.
Okay, thank you. Any questions from the audience? All right. I do want to emphasize it's a pretty unique situation that baseline approaches are compared. So typically in an assessment, you will not have the time to do multiple baseline approaches. So in that sense, I think it's really very educating to see what the impact of that is and where that comes from. So thanks, Christoph, for that work and the partners. If there are no further questions, we move on to the next speaker.
All right.
So Henri, Chalmers.
Yeah. Let me take over so that the topic I will address is the tool comparison. So we have seen the effects of baseline approach comparison. So let's have a look at simulation tools, the effect of employing different tools for assessments. So why that? So why did we did we engage into this activity? So you all know that new safety system will be there will be use cases the new safety system will have to be tested upon, and there will be an increasing number of these use cases. And it is clear that we cannot, in the future, new use cases will not be able to address all use cases by track testing. So we will have to rely massively on virtual testing, and there's a effect that has to be eliminated, has to be circumvented, is that we get variation in results coming from the use of different simulation tools, right? We want to assess the performance of the systems, and we don't want different tools to interfere. We don't want, for instance, to have exactly the same system assessed by virtual simulation and different results because different simulation tools have been used in the assessment. This is really undesirable. So these are the effects that we wanted to study, and we wanted to see whether they were important and whether they could be reduced or not. So what did we do? Oops. So what exactly did we do in the context of the project? We set a specification. So we specified a given system to be assessed, and over a set of use cases. I'll come to that shortly. And we let a group of partners to implement the specification and see whether what kind of results they got in the round-robin logic. And I just mentioned that this is in common with the Paris Initiative. So this is a consortium that aims at developing a reliable, transparent, and accepted methodology for assessing crash avoidance technologies by virtual simulation. So, as said, we chose this is fuzzy a little. A set of use cases. We chose the car to bicycle accident from the CATS project. So you can see in the table here what they consist of. So 4 constellation of car to cyclist accidents with different vehicle speeds and obstructions or not, near side, far side, longitudinal. And we would the idea was to see whether we saw. So we have had a variety of partners run these use cases. Then the measure was automated emergency braking for cyclists. Sorry, I didn't list on that. And the idea was to see whether there were differences between assessments and what was caused by the specification, the interpretation of the specification by the various partners, and which were connected to the tools themselves. And so whether we could, the question was whether we could reduce the differences to a minimum, because we don't want differences coming from the tool again. Right. So again, so we had the first run. This is published, by the way, at the ESV 2019, and all the use cases you just saw were run by all partners, and we had an analysis of the results. We looked at discrete indicators like accident avoided or not, so also the values of impact speeds, And also we looked at the timelines, for instance, speed and acceleration profiles of the vehicle under tests. And we saw variations, right? And we saw, well, we had an analysis and we saw that discrepancies or variation could appear at many stages of the simulation. In many, well, the simulation chain is a complex chain with many blocks, many systems, and yeah, there can be variation at pretty much every step. So we try to had maybe a less naive approach in the second round robin, and we try to assess at each stage or for each blocks of the simulation system, whether there were discrepancies, and try to reduce them at every step. So prior to launching the actual simulation with the treatment with the AAB on each of the use cases. So reducing the variation prior to launching, seeing that the simulation of the measure of the system as the last stage when everything has been possibly every source of variation has possibly been reduced. So let's just that's just a recall. That's the first round robin. Again, this is published. These are the types of simulation tools that were used in that first round robin, and we saw variation in time to collision calculation. The system is the autonomous emergency braking system that we implemented relies heavily on calculating the time to collision. So if there are variation in the way time to collision is calculated, this is a good cause for variations in the results. The detection algorithm also we found to be different. The collision, the detection of the cyclist, detection of the collision. Also, in the baseline, we saw variations. So all of these accumulated to generate variation in the results. So we try to reduce all of these in the second round robin. So this is an example. We found at least 3 or 4 different ways to calculate the time to collision, even the relative distance. What is relative distance between the vehicle and the cyclist? Even for that, there were variations in the tools. This was quite unexpected, but still. So again, we used in the second round robin a stepwise, what we call a stepwise approach. So let's see. Yeah. So what we did, the first step was to assess whether the tools were able to reproduce the baseline. So the baseline are the original use cases, the original accident. There is a hit point on the cyclist that is prescribed. So could the tools reproduce the baseline? Could the tools could the simulation did the car hit the cyclist at the right point, right? No treatment, whatever, just the baseline, just a simple baseline. And this was pretty much of an effort already. And what we also did, we set what we call unit tests. I will come to that shortly, what that means. So we isolated blocks in the simulation tool that could differences in implementation for these blocks could lead to variation in the results. So we isolated them and tried to test them, see whether there were differences and whether we could reduce them. So yeah, that's a view of the global process and the what was new in the second round robin is circled in red. Let's see. So so the first thing we tried to do was we sent the vehicle colliding with simple obstacle half planes, and then more complex shapes, as a square or a bicycle diamond shape. And we assessed whether there were differences in the time of the full detection of the obstacle, and whether the position of the vehicle at the time of collision there was differences in whether there were differences there as well. And for some partners, it took some efforts to reach. I mean, to be in the same range for these two indicators as the others. For instance, there were collision was not, for instance, for some partner detected at the same pace or at the same time step as the dynamics of the vehicle. So this led to discrepancies. But this has to be corrected to have a good range, to have a good accordance between the tools. One of the other kind of we wanted to assess all the vehicle dynamic itself model. So we set up a simple braking test. So that's the unit test for the vehicle model, and we were able to again reach a good degree of accordance between the partners. So you can see in green the corridors. So that's acceleration, position, and speed of the vehicle on the test, and what you see in green is the corridor. So that is a way to visualize whether there were differences or variations. Or these were acceptable, so we moved on. And also we set unit tests for the sensors themselves. So in this test, the vehicle was fixed in a fixed position. The field of view also fixed in a given position, and the cyclist would try to put the detection algorithm in complex situations. So very small angles or obstacles, and yeah, we looked at the way the sensors behaved. And so for some of the partners, the tools had to be the detection algorithm that had to be altered a little to reach a good accordance with all the other tools. And yep, so these are so there is two ways. I mean, the baseline can be seen two ways. Either the hit point is prescribed and the partner do optimize the baseline so the hit point is reached as in the specification, or the non-optimized means that the starting point is prescribed in a way consistent with the hit point, and we see how the different tools behave. And in the end, we chose the optimized baseline because all the partners could set up a baseline that would that will lead to the hit point, prescribed hit point, being reached with a sufficient degree of accordance with the others. And in the end, once all the unit tests had been run, or the baseline tests had been run, we could look at we could launch the treatment phase. So we would introduce the system itself, the measure, the automated emergency braking for cyclists, and see whether we had succeeded in reducing the variation between round robin 1 and 2. So you can see on the left of that slide one example that was run in round robin 1. So to the corridors of variation. So we are looking here at a the distance between the target and the vehicle, on the time to collision, vehicle acceleration, vehicle speed, vehicle position. And so that was round robin 1. And that was round robin 2 with all the unit test and the baseline tests run, and all the possible causes of variation reduced at each step. And so we can see that the corridors have been reduced in a spectacular ways. And so that's for the timelines. And if we look at these tables, so what you can see here, so these are discrete indicators, and the lower the number here, the least accordance between tools. So the differences, the variation between tools was here really huge in the round robin 1, and this is the same run, the same results for round robin 2. As the important numbers to look at is here, right? So this means that the rate of accordance between the tools is really low. As you can compare with what it was in round robin 1, so quite huge. So yes, we have succeeded by specifying thoroughly and running a unit test in reducing the difference into what we think is a minimum. And one other, oops, what is this here? Nope. I'm going back. Sorry. So this is these are the corridors for there. If you remember correctly, in the CATSTAT use cases, there are 4 constellations. So these are the corridors that we get for the medium field of view. So we tried 2 fields of view for the sensors in the assessment, and this is what we get at low speed. So the corridors are still large, and this is what we get without changing the sensor. This is what we get at high speeds. So the corridor width do decrease when the initial speed of the vehicle increases. And we have changed between these 2 slides. We have just changed the sensor. So we have a much larger field of view in this one, and we don't see any. This is still high speed, and we don't see any significant difference here. So, what can we conclude of this simple experience? So, we can reduce the variability in assessments. Results coming from the tools themselves can be reduced. We have to work for that on the assessment matrix, for instance. well, time the collision, or also the discrete indicators that you just had a look at. Setting simple unit tests to reduce variation at each step of the simulation is quite crucial, and it seems to us a good way to eliminate variability. And one crucial step also is to check, without simulating the measure itself, checking whether the simulation tools can reproduce the specified baseline, because if we have variation from the start, we cannot hope to have harmonized results in the end. And why does it? Oops. Why? Okay. Next steps. So the next steps is for us to share this experience we had, because we know that there is variability in track tests. That's known already. But there is also a variability coming from the simulation tool, and that has to be eliminated. So we want to share this, and also to share the fact that this variability can be reduced using specification, using thorough specification. And another activity that we see as a follow-up would be to set reference baselines that each coder could test the tools on. Also reference unit tests, setting repositories for that, for each coder to have a go and see whether how the different tools or the new tools to come to compare to the results we got in V4SAFETY. And I believe that is it for me. So if you have questions, please fire.
So thanks, Henri. Again, you can raise questions in the chat box. There's a hand by Alan Thomas. Jean-Luc, would you unmute him? Jean-Luc, can you unmute?
Hello,
yes.
hello. Can you hear me now?
Yes.
Okay.
Yes.
Yeah.
That was extremely interesting on all sorts of levels, but just referring back to experience of the UCAR pedestrian protection work that was done 20 plus years ago. We did similar round robins, and we found that, and this was with finite element such as Dyna3D, PAM-Crash, and Radios. We found there were variations between the same software on different institutions. There was even variation between the same software at the same institution, but running on different versions of the operating system of the computer itself. So completely outside. I just wondered if you'd been able to take anything like that into account, or were you just running under fixed configurations between each different simulation?
Well, each partner used its local system. I mean, we didn't. There wasn't. No, we didn't take this into account. We should have had, no two, like you said, two partners having exactly the same tools but implemented on different operating systems or machine, or we didn't try that.
Okay.
But still, that's an interesting source of variation. We weren't aware of that.
Yeah.
There
it was
is
a surprise to us as also.
There is published matter on that. Oh,
I will see if I can find it, Henri, and circulate it to all of you.
Perfect.
There's another hand by Peter Wimmer, but maybe it's dropped. Okay. Felix, did you want to react to this?
Well, I think we have to consider here a bit also differences between the simulation and passive safety, where you have to use solvers, etc. And I think the request or the need here for the active safety simulation is a bit simpler because you have forward simulations, which goes not in the complexity as we have it in the passive safety. So the observations which you made, Alan, years back, I would not guarantee that this not is happening on these simulation tools here. However, I think the risk is lower than for the passive safety part.
Yes, I would agree with that in general, certainly. Thank you.
And we haven't tested the driver models on that. There might be also more complex issues with these. Still.
Yeah. Then there's a hand by Peter Wiemer.
Yeah, I hope now my mic works. Before it didn't.
Yeah,
that's very good. But I think Felix, in the meantime, already gave an answer. I'm well aware of these variations that you raised for passive safety simulations, but also I think these simulation models are much more complex, and even because the task is distributed differently between processors, and that already has an influence on the outcome of finite element simulations.
Sure.
But for our simulations, I also would presume that they are in that sense much simpler. So I wouldn't expect these or worrying variations. But it's definitely a thing that we might or we should investigate on to run the simulations on various platforms, versions, and so on.
Yeah.
Just to be sure. That's a valuable input, Alan. Thank you.
Yeah, thank you. And also different releases of the same tool. I'm pretty sure that we will get variations in.
Yeah.
Also. I'm pretty sure.
Yes.
Yeah. So if we look, Henri, about the big improvements that you got in round robin 2 with unit tests and various other measures. So that's really a huge improvement, and the resulting range are quite acceptable, I would say.
Yes.
So can I now, as a listener, conclude that I can buy any brand of simulation tool as long as I am consistent in my quality steps?
Well, our results hint in that direction, certainly.
In that direction, okay.
Yeah.
So really, the way you use the tool is more important than which brand it is.
Yes.
Yeah. Okay.
And
Thanks.
checks you make. I mean, you have to really make checks at every steps. I mean, the way the repository I suggest. Well, this would be a long-term activity, right? Setting a repository for unit tests and baseline, but that would help definitely. All newcomers to just check themselves against what we have found. This is simple. I agree. As compared with a massive passive safety simulation, this is simple, but there's still something for active safety for ADAS and all. That would be a step already.
Yeah. Okay. Peter?
Yeah, just to comment also on that, I'm pretty sure that all the commercially available tools are perfectly fine for the task, but it's always a question of how you apply them. And so to ensure that you apply them properly, and this is also why we have V4SAFETY to set, I would say, recommendations and guidelines to do or how to do safety impact assessment properly and in a harmonized way.
Sure.
Okay, thank you, Peter. And again, Henri, I think this tool comparison is also hard to find in other publications. So typically a commercial party or research institute doesn't have the occasion to do this very often. And this was also done in conjunction with the peers network. True. So what is the link between V4SAFETY and peers? And maybe this is also for Felix to answer.
Yeah.
Yeah,
Yes, please.
Okay. So the PERS initiative exists already since over 10 years now, and we aim to continue there. And this is also a non-funded activity, but it's, I think, a great network to exchange about these topics, and was very much involved also in preparing the ISO technical specification, as well as a technical report for ISO. V4SAFETY was one project which many PERS members belong to. Well, it was, I already used the past because we're shortly to end. So then currently it's still running, which helped to dive in certain aspects deeper. For instance, what Christoph has presented, I think this would be not possible without the funding. It allowed us to elaborate on things further, which would probably take in these non-funded activity as we had it in PERS much longer time. So I think V4SAFETY and PERS are both running more or less currently in parallel, and V4SAFETY was some project which really helped to bring certain aspects forward in a faster way than PERS ever could. However, PERS will continue also after V4SAFETY, so the topics will be continued.
Okay. Then, are there any final questions from the audience? And you can raise your hands, or you can put it in the Q&A, or send us a message afterwards, of course. That's also possible. So, if not, then I want to really thank you and thank the speakers. So Felix Varenkroch, Christoph Glasmacher, and Henry Chaimowicz for preparing and holding this webinar. We hope to see you all back in the coming webinars. So there's 3 more to go. You can find them on our website under news and events. And we thank you very much for joining, and till the next time. Bye-bye.
Bye-bye. See you. Thanks.
And thanks for